Okay, and finishing up the last example here in lesson 9.3, rational functions. I listed the steps again, and again, the x and y intercepts aren't a big deal. You can just, I showed you how to do the tables on the calculator, and that's in an xy chart or xy table. So when we do that, we're going to choose some on both sides of the holes and vertical asymptotes to pick some values. So this one's a little different than the last one I just did. So what I'm going to do is I'm going to factor the top. Okay? X plus 4, that can't be factored on the bottom. But on the top, I want factors of 4 that add up to 5. So 4 times 1 would be my factors. So there's what happens. Now, if you notice, this is like a factor of x plus 4 on the bottom. That actually cancels. Okay? So, number 1, if we're looking at holes, a hole would occur when that factor that canceled equals 0. So I would actually subtract 4 to find the hole, which means my hole is at negative 4. And this is what I was talking about earlier. I would actually need to find, to actually graph it here, I'm going to have to find the y value that goes with it. Now, if you notice, the simplified expression is just x plus 1 left over 1 because these two canceled out. So if I actually plugged negative 4 in here, negative 4 plus 1 would equal negative 3. So my hole actually occurs at negative 4, negative 3. And we're going to actually make it a hole. So you can see I plotted negative 4, negative 3. There is a hole there. Okay? Now, when we plug this into y equals, you can do one of two things. Okay? I would suggest, I'm going to show you both ways. So we could either plug in before we simplified, factored and canceled, or you can basically plug in this one at the end. Now, with holes, it's not going to show you that. And if you think about f of x equals x plus 1, well, that's like y equals x plus 1. That's just a linear equation, okay, the simplified one. X plus 1 is linear, okay, with a y-intercept of 1, okay, y-intercept of 1, and a slope of 1, so rise 1, run 1, right, we'd go this way. So basically, and I'll show you either way here, but we'll pull the table up on our calculator too, we're basically going to have a line that has a hole in it that goes on forever in both directions. There will be no vertical, so there's actually, notice there's nothing left down here on the bottom. This is like over 1, so there's no vertical asymptote, okay? There's no x on the bottom anymore, so there is no horizontal asymptote either. So if I actually create an xy table, and I'm going to plug it into the calculator two ways. Okay, let's plug it in as is first without us factoring to simplify. So let's clear this one out. And now notice it was x squared. It's more than one term, so I would have to do x squared plus 5x plus 4 in parentheses, because that's all on top now, divided by, and then the bottom also has two terms, which is x plus 4. And now let's pull up our table and just see what happens here. I got to scroll. I'm still up in the 50s here, so I want to scroll back down. By the way, a quick way to get to 0, if you go to table set and you want to start, and we're going to put 0 in there, that'll get it back to 0 because I was at 46. So now if I go back to table, instead of scrolling all the way back down, here's what I want to do. Now notice at negative 4 it tells me an error right there. So negative 4 is an error, but at negative 7 we're at negative 6. So the y values are basically 1 bigger than the x values, which is kind of what that says, x plus 1. So at negative 4, now on the calculator it said error, but there's actually a hole at negative 4, negative 3. I already figured that out right here. Then at negative 5, we were at negative 4. At negative 6, we're at negative 5. Negative 7, we'd be at negative 4. If you actually plotted those, negative 6, we're down here at negative 5. Negative 5, we're at negative 4. Okay, then we have the hole there. Then at negative 3, we're at negative 2, which we have right here. At negative 2, we're at negative 1, and so on. At negative 1, we'd be at 0. So there's what it is. And I kind of indicated my hole right here. Okay. Now, if you actually put in the simplified one of just x plus 1, it's not going to, your calculator's not going to tell you an error message then. So I think it's better to put in the original rational function. So there's a couple examples. Just make sure you understand how to do it on your calculator, how to simplify, determine holes, vertical asymptotes if it's a kind of a hyperbola graph. This one's more of a line with a hole in it. Okay? And that's the lesson.